this one gives a chart. Whoops. Sorry, 1 second. So yeah, they give a chart for times and looks like velocities. Okay, Kathleen skates on a straight track. She starts from rest at the starting line at time t equals 0. Okay, for t between 0 and 12 seconds, Kathleen's velocity, k, measured in feet per second, is differentiable and increasing. Values of k at various times t are given in the table above. Okay, use the right Riemann sum with 4 subintervals indicated by the data in the table to approximate the area, the integral from 0 to 12 of k of t. Indicate units of measure. Is this approximation an overestimate or an underestimate for the value of the integral, and explain your reasoning. Okay, so we could do this without drawing a picture. So I'm going to do this without drawing a picture because just it's faster. Okay, and we've done enough of these. I think most people were doing them without pictures anyways. All right, so if we're going to use the right Riemann sum, first of all, each subinterval will be kind of consecutive. We'll use kind of consecutive columns for each subinterval. So we look at the first subinterval from 0 to 3. So the width of the subinterval is 3. Actually, I'm going to kind of write it like this. Okay, from 0 to 12. Okay, this is approximately equal to 3 times 5. Okay, so this is the area of this is going to be the area of the first rectangle. So 3 is the width because that's the difference between the two t values, and then 5 is the height because we're using the right hand. If we're using these two endpoints for the first subinterval, 5 is going to be the one on the right. And we're just going to kind of do that for each one. So we'll plus, okay, the next subinterval, the width is 2. And then again, we'll use the right hand value, which is 10. Okay, the next one, the width is 3. And using the right one, we'll use 20. The last one, the width is 4, and it'll be times 24. Okay. Okay, so this is 111, 191. Okay, and then if the function is in feet per second that we're integrating, then we're going to end up with, this is going to be feet. Okay, this will be an overestimate for sure because the function's increasing. So that means that in each, in the first subinterval, 5 is like the highest value, between these two values, and that's the one we used. And the next subinterval, the two values were 5 and 10, and we used the bigger one. The next one was 10 and 20, and we used the bigger one. So if we're always using the largest value for the height in each subinterval, then it's going to be an overestimate. And they also tell you it's increasing always, and that's going to be true anytime you have an increasing function. The right Riemann sum is always going to be an overestimate, and the left is going to be an underestimate. So, next one. Okay, another chart. Same same variables. So you have time, this one's in seconds, and then you have velocity in meters per second. Okay, velocity of a particle moving along the x-axis is modeled by a differential function v, where the position is measured in meters and time is measured in seconds. Selected values of v are given in the table above. Okay, the particle is at position x equals 7 meters when t equals 0 seconds. All right, using correct units, explain the meaning of the integral from 20 to 40 of v of t in the context of this problem. Okay, let's do that first. Okay, the meaning of that integral, if you do an integral of velocity, that's going to be the change in position. And so that's what this is. So this integral, 20 to 40, is the change in position. It's not the final position, but it's the change in position times t equals 20 to t equals 40. Okay, so next we'll use the use a trapezoidal sum with 3 subintervals indicated by the data in the table to approximate that. Okay, if we're going to use the trapezoidal sum, and we're only going from 20 to 40, and if it's 3 subintervals, you know, this will be one subinterval, this will be the next subinterval, and this will be the next subinterval. Okay, so we're only dealing with those last 4 columns. Alright, so here, I'm going to do it off to the side here. Alright, so area of a trapezoid, 1/2 b1 plus b2 times height. Okay, the height is the change in times, and then each of these bases, each of these are the heights, you know, the velocities in this case. Okay, and that's the 2 velocities that are in each subinterval. Alright, so we're just going to be adding these 3 times, you know. I'm going to kind of pull out the half, you know, because we're going to have a half multiplied each time. So when I do this area, I'm going to pull out a half, and then we'll just kind of write the sum of the bases times the height for each trapezoid. Okay, for the first one, we'll just do the sum of the bases, -10 plus -8, -10 minus 8, times the height, which is really the change in time, which is 5. Do the next one, -8 minus 4, change in height is 7. Last one, -4 plus 7, change in height is 8. Okay, the first thing, -18 times 5, 90. Okay, next one, -12 times 7, 84. And then the last one is 3 times 8, which is 24. Okay, that's a half times -150, which is -75. Okay. and this will be feet. Or meters. What am I talking about? Okay, was that everything? Yeah. Okay, this next one, they give a graph of g prime, and they say the function g is defined and differentiable on the closed interval from -7 to 5 and satisfies g of 0 equals 5. The graph of g prime of x, the derivative of g, consists of a semicircle and 3 line segments as shown. Okay, find g of 3 and find g of -2. Okay. Okay, so these, we're going to do a similar way, but there's going to be just kind of one little difference. Okay, so think about when you do integrals. Remember, integrals give you change in the, like integral velocity gives you change in position, right? So like if you integrate velocity, this gives you the change in position. But think about velocity is the derivative of position, right? So if you take the integral of the derivative of a function, it gives you the change of that function, right? So if we do the integral here of g prime, and let's say we do it from 0 to 3. So this will give us the change in g, the change of the value of g from 0 to 3, and that'll help us find g at 3, because we know g at 5, or g of 0 is 5. So at 0, g is 5, and then if we can figure out how much g changed from 0 to 3, we can just add that to 5 to figure out what g is at 3. So, okay, so really, I'll put this, whoops. Actually, let me move this over. Okay, so what I'm going to write, so g of 3 is really 5 plus this integral. Okay, so that's the most important thing, is just understanding that, I think. Okay, so now we have to find this integral, and we'll do that by looking at the graph and interpreting it as area. Alright, so we can see at least from 0 to 2, the area under the curve is a quarter circle. If this was a full circle, the area would be 4 pi, because this is a circle radius 2. So this whole area would be 4 pi, but since it's just a quarter circle, that's just going to be pi. And then now the area from 2 to 3, because we need all the area from 0 to 3, so the area from 2 to 3 is going to be 3 halves, just the area of that triangle. Okay, and then that's it. So just add those together. So that'll be like 13 over 2 plus pi. Okay, so that's g of 3. Okay, g of -2, a little different, but same kind of idea. Okay, so we want to find g at -2 here. If g at 0 is 5, okay, sorry, I'm kind of picking back up after not doing this for a while, so hopefully, so if there's like a little weird break, that's why. All right, so for the next one, g of -2, we'll start off the same way. Wait, where's the, oh, sorry. Oh, yeah. So we'll start off the same way. Wait, sorry. Okay, yeah, sorry. We need to, so do you notice if we want g at 2, if you think about it, g of 0 is 5. Okay. And then if we can figure out how much it changed from -2 to 0, what this change was, do you get that we do 5 minus that, because to see where we would end up at g of -2? And so that's really what we're going to do. We're going to find this area and subtract it. Okay, another way to do it, just to see different ways. So we'll take 5 and we'll really add from 0 to -2 g prime of x, like that. Okay, so notice that the lower limit is bigger than the upper limit. So really this is like the negative of the area. And that's really what we want. We want to subtract the area that we're going to get from 0 to 2, or from -2 to 0. And so this will, whatever this is, this will be our answer. All right, so we can see this is 5, and then we've already done this from -2 to 0. This area is the area of a quarter circle, just like it was when we found it over in this part. And that area, this area is just pi. So this is going to be 5 minus pi. And that's it. Okay, so here, so first it asks us to find f prime of x. Okay, so remember how to take the derivative. F is defined in terms of an integral, so we're basically taking the derivative of an integral. And to remember how to do that, there's really not much math involved, and it definitely doesn't matter what this function is. Like, this could be something really complicated in here. It doesn't really matter because we're not really doing much math with it besides substituting into it. And so what you'll do is you'll take the derivative of the top limit and then times that by whatever you get when you plug the top limit in for the variable in here. So we'll plug 3x in for t there. Like that. And then technically you would do minus and then do the same thing, but the derivative of the bottom is 0 times whatever. That'll just be 0. And so that's it. That's f prime of x. And you could have simplified it if you want. Like that. So either one of these would be acceptable. Okay, next one, g prime of x. Okay, so we'll start out taking derivative. So it'll be f prime of sine x, okay, and then times cosine x. It's like chain rule. And then we've already found f prime of x, so now we'll plug sine x into that. This equals 3 square root that, and then just times cosine x on the outside. Okay, wait, let me make sure everything's good. Yeah, okay. Oh, that should be a sine squared. What am I doing? Ooh, this should be a sine squared. We're just plugging sine into there. Thought I did something wrong. Okay, and then also the cosine just goes on the outside. Okay, this one gives you a graph of f, and that says the continuous function f is defined on the interval from -5 to 8. The graph of f, which consists of 4 line segments, is shown in the figure above. Let g be the function given by that. Okay, first part says find g prime in terms of f. Okay, so we're going to take the derivative of g over there. So g prime. Okay, first derivative of 2x here is just 2. And then when we take the derivative of that integral, we have a constant on the bottom and an x on the top. So this is just going to be f of x. Okay. All right, and so that's that part. Okay, the next part, they asked us to find g double prime at 4 and g double prime at -2. Okay, so we'll take derivative of g, get g double prime. Derivative of 2 is 0, so that's just f prime of x. And then now we'll find these values. So g double prime at 4, g double prime at -2. Okay, so we don't know anything about g except how it's defined in terms of f, and then we know a lot about f since we have the graph. So let's get these in terms of f now. So this will really be g double prime of 4 is just f prime at 4. Same thing, this is f prime of -2. So we'll really be using those to evaluate g. We'll be using f. Okay, so this is asking for the slope of the tangent line of f when x equals 4. Oops. So when x equals 4, they want the slope of the tangent line, which is really just the slope of this line. So you just do slope formula. So that would be -1. Okay. And you can do like 3 minus -3 is 6. 2 minus 8 is -6. 6 over -6 is -1. Okay, f at -2. You can see at -2 there's a corner. So the slope of the tangent line is undefined there, or does not exist. Okay. Oh, they say or state that it does not exist. So here we'll do that. Okay, another graph of f, very similar problem, starting out with at least. Okay, the continuous function f is defined on the closed interval from -6 to 5. Figure above shows a portion of the graph of f, okay, from -2 to 5, consisting of 2 line segments and a quarter of a circle centered at 5, 3. Okay, so here's the center of this circle that would go that way. Okay, it is known that the point 3, 3 minus root 5 is on the graph of f. Okay, so that's this point here. That's 3, 3 minus root 5. Okay, if this equals 7, find the value of that. Okay. Okay, so if you think about it, this is the area of the graph from -6 to 5, so that's all the area. This is the graph from -6 to 2. So do you get that the area under the graph from -6 to 2 plus the area under the graph from -2 to 5 equals the area under the graph from -6 to 5. Like that. Right, this goes from -6 to 2, from 2 to 5. This goes from 2 to 5, so that's the whole thing from -6 to 5. Right, -6 to -2, -2 to 5, and that's the whole thing. Okay, so we're given that negative 6 to 5, that's the right hand side. This whole thing equals 7. We don't know this first one, but we can find this from the graph, the area from negative 2 to 5. Okay, so let's do that. Okay, first thing that I would note is that this area from negative 2 to 0 here, that cancels out. You know, this area here, this is a half, and this is negative a half. So those cancel out. So we don't have to worry about that area. Okay, so kind of similarly, this area here cancels out with that area there. So we won't worry about that either. Okay, those each look like they're a fourth. That's 1/4, and this is negative 1/4. Okay, and then now this area here is 2. This is 2. You can see, however you want to look at it, I was seeing like this area is 2, but this is half of that, and then this, so that this is 1, there, that, and then this is 1 also. Okay, and then the area of this part, this is a quarter circle with radius 3. Okay, so if it was a full circle, the area would be 9 pi, but since it's a quarter circle, it's 9 pi over 4. Okay, and then this whole square, the area of this would be 9. So the area of this is 9 minus this. The area of that is 9 minus 9 pi over 4. Okay, and then keep in mind this fourth and negative fourth canceled out, and this negative half and half, those canceled out, all those areas. Okay, so we're just left with adding up these 3 areas. Okay, whoops. Okay, so let's go back down here. Okay, so that's the area from negative 2 to 5. That's this area. Okay, so this 2 plus 9 is 11, and then 9 pi over 4 minus pi over 4, 8 pi over 4, which is 2 pi. This is really just 11 plus 2 pi. Okay, and then now we still need to find this. All right, so all you do is subtract these from that, and that'll be it. If we do that. So it'll be 7, so that's negative 4 minus 2 pi. That's it. Okay. Okay, this next one. Okay, so I'm going to use properties of integrals first. So we can split this up. Okay, and then if you need to, so now to evaluate this integral, we need to take the antiderivative of this. But the antiderivative of a derivative is just the regular function, because an antiderivative is the function that if you took the derivative would be this. So that's just f. If you took the derivative of f, it would be f prime. So this is really 2. And then just f of x evaluated at 5 and 3. Okay, and then this one, I don't know if you remember to evaluate the integral of just a constant. You do the constant times these subtracted. Okay, this one is f of 5 minus f of 3. And then this will be 8. Okay, f of 5, the graph is 3. And f of 3 is 3. Okay. So this is just 2 times 3 minus 3. And that's just 8. Let me make sure I read that right. 5 and 3. Yeah. 5 and 3. Yeah, okay. Alright, so that's it. Okay, so we're using the same graph, so we're just doing part C. Okay, the function g is given by that integral. Find the absolute maximum value of g on the interval from -2 to 5. Okay, finding absolute maximum value. Doesn't matter, even though this function is defined in a strange way, doesn't matter. You do the same thing every time. You find critical points, so we'll find the critical points of g, and then plug those and the endpoints back into g to see which one's the biggest. And that's it. So to find critical points, we take derivative. Okay, and that's just f of x. Okay, and then now we set this equal to 0, or see where it's undefined. F is never undefined, you know. It's defined, f is defined everywhere. Okay, so the only critical points will be negative, you know, we want to find out where f equals 0, so that's -1, 1/2, and 5. And 5 was an endpoint anyway, so. Okay, so now we plug these and the endpoints into G. So I'm going to do that. So we need to do G of -2, G of -1, G of 1/2, and G of 5. Okay, so we can see G of -2 is going to be 0 because you know, we're using this integral to evaluate G. So, you know, all these x's are getting plugged into that top limit. So -2 gets plugged into there. So -2 to -2. And that's just 0. So just remember, anytime the limits are the same, it's going to equal 0. Alright, I knew I was going to make, this is not going to have enough room. Well, I even did that. Okay, next one, G of -1. Okay, so -2 to -1. We can see that area is 1/2. Right, from -2 to -1, the area under the curve is 1/2. Okay, so now -2 to 1/2. Okay, so from -2 to 1/2, these two areas cancel. And then this area, this little bit of area here is going to be a quarter, but so that's going to be a negative 1/4. Okay, and then the last one, g of 5. Okay, and that's just all the area added up. So here, I'm going to get the graph from the other one real quick. So here it is. Poof. Okay, so that had all the areas in it. So we realize these, oh, we did that already, that whole thing. Okay, so that's just this positive area, 11 plus 2 pi. Okay, yeah, because these can, because all this area, now we want to do all the area from -2 to 5. All right, that's what this is. And that's just all these threes added up, since these canceled out. Okay, so that's 11 plus 2 pi. Oops. And that'll definitely be the absolute maximum value. Okay, remember when they ask for the maximum value, they're asking for the actual value, like the answer, as opposed to the x value. You know, if they asked when does the maximum occur, it would be at 5. Okay, last thing, and this is tricky. Actually, I'm going to make this a bonus question. So, okay, first thing to do with limits is plug in the limit. So let's say we just plug in 1 to everything, see what we get. So we get 10 to the 1 minus 3 times f prime at 1. F at 1 minus arctan of 1. Okay, 10 to the 1 is 10. 3 times, so f prime at 1. Okay, so that's the slope at 1, which is the slope of that line, which is 2. Okay, and then at the bottom we need f at 1. F at 1 is just 1. It's just this value is 1. And then arctan of 1. So it's like, where does tan equal 1? So that's pi over 4. Okay, and then that's, you know, you could actually, if this is the AP test, you could just leave it like that, and, you know, that could be your answer. I'll clean it up just because probably most people did, except for Danny. Danny didn't. Danny left it like that for sure. No, just kidding, Danny. All right, and then we could do, this could be like 4 minus pi over 4, and then, oops, and then those would cancel, so this is 1 all over 4 minus pi. That. Okay, so it looked like it was going to be some kind of a L'Hopital's, but couldn't use L'Hopital's for this because it wasn't 0, 0. You didn't need to, actually, so. Okay, so that's it for that one. Okay, last problem. Find the average value of f on the closed interval. Okay, average value has a formula. Okay, for us, b and a are 5 and 0, so this is just 1/5. Okay, so to find the area from 0 to 5, we'll first find the area from 0 to 3, because it's that one piece. and that piece is x plus 1 to the 1/2. And I add it to the area from 3 to 5, the other piece of f, like that. Okay, actually I'm going to use big parentheses because we'll use brackets for that. Okay, so the integral of x plus 1 to the 1/2 is x plus 1 to the 3/2 times 2/3. Okay, and then that'll just get evaluated from 3 to 0. Okay, and then the integral of 5 minus x is 5x minus square root of 2. Okay. Okay, so I'm actually going to pull out the 2/3 from there. And then if we plug in 3, we'll have 4 to the 3/2 minus, plug in 0, you have 1 to the 3/2. And the other one will just be 25 minus 25 over 2 minus 15 minus 9 over 2. Okay. Okay, 4 to the 3/2. So first you do square root of 4, which is 2. To the 3rd is 8. And then that's minus 1, so that's 7. And then 25 over 2. Actually, here, we'll do it this way. 25 minus 15 is 10. And then this is negative 25, really, plus 9 over 2. Negative 25 over 2 plus 9 over 2 is negative 16 over 2, which is negative 8. So that's really, those two are 10 minus 8 is 2. Okay, so that's 1/5. 14 over 3 plus 2, which is 6 over 3. 20 over 3. 4 over 3. Okay, so that's simplified a lot. Okay, so that's the average value of this function on that interval. And that's everything.